All right, so this is day 2 on functions, relations. Yesterday we were comparing data and identifying whether if it was a function machine or if the machine was broken. That's where we call it just a relation. Let's have this first question as our opener for today's notes. It says evaluate y equals negative 3x plus 4 when x equals 2. How do we do that? We plug what in? 2 for x. That's right. So we're going to take the value they give us, x equals 2, and we're going to plug it right into that x value right there. And what was the tip that I gave you whenever you plug in? Parentheses, right? Rewrite it, negative 3, parenthesis instead of x plus 4, and then you could safely plug in that value of 2 and work it out, and you will get negative 6 plus 4, which equals negative 2. So, in a sense, the input x gave us the output negative 2. The x value of 2 gives us the y value of negative 2. That's technically a coordinate, right? But anyway, what I want to get at today is function notation. And when we think about the word notation, it's really just a way of writing, of notating something down. So instead of saying all of these instructions, I could rewrite it in function notation without having to write everything. Function notation is simply this. F of x is the same thing as y. Write that down in your notebook. F of x is the same thing as y. I mean, technically, it doesn't have to be f of x. It could be g of x, h of x, q of x, r of x. But that's how we read it. When you have, this is not saying f times x. This is saying f of x. So f of x is the same thing as y. Imagine this. Imagine this original y, instead of it being y, imagine it being f of x. Because after all, f of x is the same thing as y. So if I did have f of x equals negative 3x plus 4, instead of y equals negative 3x plus 4, if I had that, if they gave me that, then I know that this is the function f of x, and all they have to do to instruct me to do this is write this, f parenthesis 2. That's saying f of 2, okay? So instead of me saying evaluate the function when x equals 2, in function notation, we know that f of x is the same thing as y, and when they say f of 2, that's simply saying take the 2 and plug it in. So you don't have to write this whole sentence of instruction. I could just write this down, f of 2, and it's telling me to plug in 2 right into the x the way we did, and of course we'd get out a negative 2. This might not make too much sense right now, but let's go over some more examples and it will make more sense. Check it out. Everybody jot down these 3 different functions that we have above. We have f of x equals 2x minus 1, g of x equals x squared minus 3x plus 2, and also h of x equaling negative 4x. Again, we're using function notation. This is not saying f times x. That's incorrect. This is f of x. In other words, the f of x, the g of x, the h of x, instead of them being y, we give it a certain name. This is the f of x function, this is the g of x function, the h of x function. If we had a bunch of y's, if I had a y right here, a y right there, and a y right there, and I told you, hey, look at the y function, well, you wouldn't know which one to look at. But because they have a specific name, f of x, g of x, h of x, now you know which one to look at. And this notation saves us a lot of time. I don't have to tell you, hey, take this function and evaluate it when your x value is 5. That's all said right here with that notation, h of 5. Okay? So the notation is telling you to go to your h of x function, this guy, and plug in 5 in place of x. So Enrique, if I asked you what is the difference between h of x and h of 5, what's the visual difference between this guy and this guy? Right, what do you have right here? And what do you have right here? So that's telling you take your x and replace it with the 5. Okay, so let's write down the h of x. Now, if I had an f right here, I would use this one. If I had a g, I'd use this one. But it says h, so I'm using this one. but instead of x, I'm going to replace the x with the 5. So we're just going to simply do this math. Negative 4 times x, but instead of x, we're putting in this 5 right there. And the final answer is negative 20. Done. So function notation just saves you a lot of time from reading instructions. So like right here, f of negative 3 doesn't mean f times negative 3. It's saying go to your f function and evaluate when your x value is replaced with negative 3. All of that is said with this symbol, with this notation. All right? So let's go to the f of x function, and let's take that x and replace it with the negative 3. Again, the best way to approach this is to replace your x with parentheses, and then plug in, or do the replacement. Plug in your negative 3 in place of x. So you're going to plug in that negative 3 right in there, do the math, multiply 2 times negative 3, that's negative 6, but we still have the minus 1. Negative 6 minus 1, final answer is negative 7. Let's try one more. G of negative 3. So which function am I going to go to? The second one, the g of x function, right? And what am I going to do with these x's? I'm going to change them to what? To negative 3's, right? So the safest way to do it is to rewrite it exactly the way it is, but instead of x's, put parentheses. And then we're going to plug in those negative 3's right in there. So negative 3 right there, negative 3 right there. Then we're going to do some math. Of course, we're going to be using PEMDAS. So let's do the negative 3 squared first. That's 9. And then I guess I'll do 2 steps in one. Let me multiply next after exponents. We have a negative 3 times a negative 3. That's a positive 9. I'm going to bring down the plus 2. At the very end, I'm going to do the 9 plus 2. That is 20. So there's our answer. Let's move on. So we are going to get a little bit more challenging. It'll get a little weird right here. We're going to try the next couple. Please write them down. So number 4, this one's interesting because it says h of negative 1, and that's telling us to do something. It's telling us to go to the h of x function and plug in negative 1, but then at the end of it all, it says plus 1. Okay, so let's do h of negative 1 first, get an answer, and then at the end of it all, add 1 to it. So let's go to the h of x function, which is negative 4 times x, and of course, we're plugging in a negative 1 right there. And then at the end of it all, we are going to do this plus 1. So I'm going to put plus 1 at the end of it all. So let's do the math. We have negative 4 plus 1. Negative 4 times negative 1, that's positive 4. And positive 4 plus 1 equals 5. Let's move on to number 5. Number 5 is really interesting because if it said h of 7, what would I do? If it said h of 7, you'd put 7 into the h of x function. Yeah. But it doesn't say h of 7. What does it say? H of x plus 1. So this is it's not a regular number, it's a binomial. We need to take that binomial and plug it into the h function. Okay? So we need to take that x plus 1 and plug it in right in there. Does that make sense? So what is it going to say? It's going to say negative 4 times x, but instead of x, what am I going to write? X plus 1. And then I'm going to simplify. Now what do I mean by simplify? Distributed property. Negative 4 times x, negative 4x, negative 4 times 1 is negative 4. So there's your final answer for number 5. Now, most of them are easy. Just h of 5, plug in 5. F of 2, plug in 2. But 5, 6, and 7, these are the advanced questions that I'm throwing at you. So, number 6, f of 3b. That simply means go to your f function and plug in what? 3b. 3b, that's right. So, your f function is up here. It's 2x minus 1. So, let's write it with parentheses first. 2x minus 1, and we are plugging in a 3b in place of the x. So we plug in a 3b in place of the x. And now we could actually simplify doing the math. 2 times 3b is what? 6b. 2 times 3b is 6b. That minus 1 at the end, you just bring it down and you're done. 6b minus 1 is your final variable expression for number 6. Number 7 is super interesting because inside there's a f of x. And normally we have a number right here, right? Like if I had an h of 5, what would I do?
You would
put a 5 into my h function. But I don't have a 5 right here. It doesn't say h of 5. It says h of f of x. So I need to literally take the f of x function and plug it into the h function. So f of x is really 2x minus 1. So this is what we're going to be plugging into the h. Does that make sense? So h is really negative 4x. Let me write that down. Negative 4 times x. But instead of h of x, we have h of f of x. And we know that f of x is really 2x minus 1. So we need to actually plug in the 2x minus 1 into the h function right there. So when you plug in 2x minus 1, then you could distribute and get your final simplified answer, which is negative 8x plus 4. Kind of crazy? A little. Let's check out the homework for today. On this assignment, half of it is doing what we were doing yesterday, just identifying is it a function or a relation. So if the machine's broken, obviously it's not a function, it's just a relation. So like number 5, is that a function or a relation?
That is a relation.
A relation, because the input 5 gave you a negative 3, and if you plug in a 5 again, it better give you a negative 3 again, but you see it doesn't. Give you something totally different that's broken, so that's just a relation. So we're going to be doing that for half of the worksheet. Now down here is the new part where you have your f of x function and g of x function, and they simply tell you, hey, plug in 4 into the f of x function, plug in 8 into the f of x function, plug in 2 into the f of x function, and then get an answer and then add 1 to it. So the homework's pretty easy. We'll have a separate video on the homework. Let's get started.